Hello everybody and welcome back. So in today's video, what I'm going to be doing is teaching GitHub fundamentals. So essentially everything you need to know to be effective using GitHub and all of the common commands that you'll use 99% of the time. I will note that Git and GitHub are extremely complicated tools when you get to the advanced level. There's a lot of things that you can do, and there is like thousands of commands and variations of commands that you can use within Git and GitHub. Of course, I'm not going to be showing you all of those. These are kind of things that if you need to use them, you're going to look up and use them once in a blue moon. The stuff I'm going to be showing you here is what I can almost guarantee you'll use literally 99% of the time. So with that being said, what I'm going to do in this video is really focus on actually trying to teach you how Git and GitHub work. I don't want you to just memorize the commands. I want you to actually understand what those commands are doing so that if something goes wrong or you need to figure out what command to use, you actually have some idea of what's happening on a lower level. So with that being said, I'm going to hop over to the kind of blackboard here where I'm just going to do some drawings and illustrations, talk about first the difference between Git and GitHub, then we'll talk about the workflow of GitHub, we'll talk about branches, and then we'll actually get into all of the different commands, and that will probably be near the second half of this video. So I'm here on the blackboard, and the first thing that I want to discuss is the difference between Git and GitHub. So a lot of people seem to think that Git and GitHub are one and the same, that they're the exact same thing. That is not true. These are actually different things. They obviously integrate very well with each other and they're very similar in what they actually do, but they are two separate things, and I think it's important to understand the difference. GitHub is really just a website. I like to think of it as kind of like a nice add-on or extension to Git. And what GitHub does is it gives us a nice UI, it gives us some features that Git doesn't have, and it lets us host remote repositories and work collaboratively with a lot of other people. Now what Git does is this is actually what handles all the version control stuff. So when you're doing something like merging code together, or when you're doing something like making a commit or making a change or pulling or pushing, you're using Git. Git is the version control software. This is what we're really going to be learning, how Git works. GitHub is kind of just like a layer on top of Git that gives us a bunch of commands, it gives us a bunch of UI features, it has a fancy website, and it has a bunch of other things that Git just doesn't have. So these are two separate things. Please do not confuse the fact that they are the same, and I want to make it clear that we can use Git without even having to touch GitHub, because GitHub is not required, is not a dependency of Git. It is just something that we use on top of Git, and there's lots of other tools that go on top of Git as well. So with that being said, let's actually get now into kind of the workflow when we use a GitHub repository. And let's actually discuss what I mean when I say the word repository. So let's go here. So to kind of explain what I mean by repository and to go through the differences of what we call a local and a remote repository, which I think is the first important thing to understand, I want to consider an example where we have a team of 4 developers. So let's say we have 4 people and they're working on some kind of game. Well, what these people probably want to do is they're all going to have their own machines, they're all going to be coding, and they want to kind of sync up with each other, right? When one person finishes a feature or they make some changes, they want to send it to the other person. When the other person has some changes, they want to send it to them, and they want some kind of system that keeps track of those changes, and that means that, everything goes fine. So essentially, we're not sending zip folders to each other. We actually have some kind of automated system like Git that is controlling this version control stuff for us. So let's say we have our 4 developers. What I'm going to do is I'm going to draw 4 boxes down here in the corner of my screen, and these will be my developers. Now here, we're going to draw a big circle, and this is what I'm going to call my remote repository. So a repository is really just a store. It is a place where we have a bunch of code, and it can be remote or it can be local. A local repository is something that sits on your machine, so it sits on your end in front of you. Other people don't see it. It's your version of the code. That is a local repository. So each of these 4 developers have their own local repository on their machine. So let's say we started out in development and we just started, there's a little bit of code that already exists. The first thing that all these developers would do is they'd look at the remote repository, which is going to be kind of our source of truth. This is going to be the place that really has all of the up-to-date code. This is where all of the changes go to. This is where it starts from. This is where we have the most recent version, the version that's working. That's what we think of when we think of a remote repository. This is the place that all 4 of these developers kind of trust, that has the most up up-to-date version, and they'll be making changes to this place, and they'll be asking for new changes, and that is what the remote repository does. So essentially, these 4 developers have 4 local repositories on their computer. They are some kind of version based off of this remote repository. They'll make changes on their local version, and then they will push those changes to the remote repository, and when someone else makes some changes, they will pull those changes down. So this is the basic workflow, right? We have this remote repository. When we start out, all of these developers kind of take a copy of this repository. So they'll say, okay, let's copy it onto our local machine. So let's say at the very beginning, at time 0, all of these developers have the same copy of this remote repository. Now let's say, developer 1 starts working on a new feature. Well, his code base immediately locally is going to look different than developer 2, and it's going to look different than the remote repository, right? That's just how it works. So let's say developer 1 makes some changes on his local machine. He tests them out, they look good, then what he does is he says, okay, let me push these changes to the remote repository. I want my other teammates to see them, I want to check it in, I want to make sure everything's good. So he pushes those changes to the remote repository. Now, the next day, he says to developer 2, hey, I made some changes, pull those down from the remote repository. What he does is he asks the remote repository, hey, give me any new changes, and then it compares the remote repository with his local repository and changes anything that changed. So it gives him all of these new changes. Maybe a new file was added, maybe some files change lines, whatever. That's what Git does for us. It pretty much handles the interaction between changes and making changes, right? Like that's all it's really doing. It's when changes happen, Git handles that for us. And the nice thing with Git is that since it is a very complex tool, it can do things like automatically merge code together. Like let's say you and I have worked on the same file, but we changed different parts of those files. Well, Git can actually figure out what's happened in those 2 files and then automatically merge those changes together such that there's no conflict. Now, sometimes there is, but that's beside the point. This is kind of the basic workflow of Git, and that's what I wanted to cover here. All right, so the next thing I want to talk about is Git History and Branches. Now, this is really important, and if you can understand this part here, you're pretty much going to be good to understand like 99% of GitHub, or the stuff that you're actually going to have to use. All GitHub really does for us is track a history of what we call commits. Now, a commit is simply a change that you've made. Now, that's not necessarily like you change one line of code. I wouldn't call that a commit. What a commit is essentially you make a bunch of changes on your local machine, and then you commit those changes. So you say, hey, I want to save all these changes. I want to bundle them up into their own little package, and I want to store the fact that I changed all of this stuff at this point in time. That's what a commit is, essentially like a checkpoint, a way to return back to a previous point if something goes wrong. So not every single time you save a file are you making a commit, you have to actually manually make a commit. So let's say I add like a new feature or I have a bug fix. I would commit that so that way, say I mess something up in the future in the code base, I can always come back to that commit and say, hey, at this point in time, this was working, this was functioning. That's the point of a commit, and it stores a bunch of data with it. Who made the commit, what time the commit happened at, who changed what files, when they were changed within each file. It stores a ton of different information, and that information is really valuable when we start talking about branches and kind of a timeline in GitHub. So we have all of these commits, and commits are just changes. What you do is on your local machine, so in your local repository here, you make a bunch of changes, you do whatever you're doing, and then you commit those changes locally. So inside your local version of the repository, you commit those changes. Once you've made all of your commits, so you can make multiple commits, it doesn't make as many as you want, just checkpoints, you're just saving whenever you want to essentially. You will take those commits and you will push them up to the remote repository. So this is your local repository, and this would be the remote repository. Now, the remote repository will have a look at all of these commits, and it will attempt to bring all of those commits and push them into the branch of the remote repository. So I haven't talked about branches yet, so I'm trying not to say that word, but essentially just imagine it takes these commits and it somehow kind of merges them with the existing code base and adds them into that. That's what happens when you push commits up. Now, let's say that you're on a local repository, and it's been a few days since you've updated your repository. The remote repository has changed. People have made some changes. Well, what do you need to do? You need to get those changes. So what you do is you do what's known as a pull. So you pull all of the changes down from the remote repository. So let's just say the remote's up here. Pretend this one's gone. You pull all these down, and then what it does is it gives you all of the new commits that have happened since you last pulled down these changes. Now you have all these commits coming from the remote repository, and you merge them into your local repository. So you take them and you combine them with the work you currently have, and that is kind of how this system works with a bunch of commits. Now what GitHub does for us is it tracks all of these commits. So let me attempt to erase all this. Let's get rid of that as well. So in GitHub, we have these things called branches, and the first branch I want to discuss is what's known as the master branch. Now we have all these commits. These are all our checkpoints, all our kind of saves, and we push commits up and we pull commits down. Now the remote repository, and even your local repository as well, keeps track of all of these commits and everything that happens to the repository. So if at any point in time something goes wrong, I can always roll back to a previous commit, or I can just look at all of the history and what's happened in this code base, which is very valuable. So all of these dots that I'm going to put here are commits. And imagine this being a timeline where back here is in the past, previous commits, and right here, so at the very end of the timeline, is what the current code base looks like, and it's the most recent commit. So it stores all of these commits kind of on this timeline. Maybe they all happen from different people. Maybe they're all the same person, whatever. There's just all these commits. These are all the changes that happen. Now, this is on what we call the master branch. So the main branch of our repository is really just what we think of when we think of the code base. We have a branch, and a branch is just one version of this code base essentially, and it's hard to describe until I show you what another branch looks like, but just imagine that the core code base that you're looking at is pretty much always going to be the master branch. Now, this master branch is what we want to make sure is always working. Think about if we're working on a large project. I don't want to modify this master branch with some code that's broken or not working, right? Because if another developer pulls it down, now all of a sudden their local repository is messed up because you've made a change to the master branch. They pull down the master branch, and now they're all, they're all messed up on their end because you made a bad change to the master branch. So instead of always making changes to the master branch, so instead of always putting these bubbles, so these commits, right onto here, sometimes what we use is what's known as another branch. And what a branch essentially is a copy of a repository at a certain point in time that has different changes. So let's do this. So another branch could look something like this. So maybe this branch I'm going to call feature, or like new feature. So whenever you have a new branch, you give it a name, you can call it whatever you want, and the point of this branch is to essentially be able to work on a new feature, push it up to the remote repository without actually directly putting it into the master branch. So if I make a new branch, maybe I branched off starting at this point right here. So I branched off at this point in time, at this commit. Now this branch has whatever the repository had up until this point, right? So everything behind it, it has all of those changes. And you've branched off, and now these dots here are your changes on this branch. So you are just making different changes on this branch so that you are not affecting the master branch until you're sure that this branch is fully functioning. Because imagine, say you and 4 other developers are working on a new feature, you're not done yet, you haven't finished it, but you need to work on it together. Well, you might make a new branch off the master branch so that you don't affect the master branch of code, the stuff that everyone else sees, and then as soon as this branch, you're satisfied that it's actually working, that everything is good, what you do is you merge it with the master branch. So you take all of these commits here, and you say, okay, I want to merge those into the master branch. And then Git does its magic, which I won't really discuss, and it takes all of these commit messages and aligns them onto this master branch in the order that they should go and makes all of the appropriate changes. That is essentially what happens when you have what's known as a branch. And again, you branch off because what you want to do is make sure that you're not modifying the master branch until you're sure what you're doing is working and functioning. And of course, on this branch here, on this feature branch, you can still update this branch from the master branch. What you can do is you can say, hey, give me all the most recent updates from the master branch, throw them on here so that this one is staying up to date with the master branch, but it has some new changes that aren't yet in the master branch. That is what another branch is kind of meant to do, and you can even branch off from branches. So when you get into really complicated projects, maybe you have like another feature you're working on top of a feature, well, you could branch off from another branch, merge it onto this branch. So merge like that, and then merge all of this onto the master branch. I know. Okay. So this was a long explanation of branches, of Git, of GitHub, but I think we've gone through a lot of theory. Most of the theory we kind of need to understand. And now it's going to be really easy to get into the commands and start actually doing some examples. So with that being said, let's head over now to kind of the terminal and actually GitHub, and let's set up a repository. Let's go through some examples and let's learn what these different commands do. Alright, so I'm on GitHub here, and I actually just wanted to show you an example of a large repository and what it kind of looks like in terms of branches and commits before we get into the commands. So this is actually the repository I work on at work. So I work at Microsoft. This is an open source repository. This is the extension for VS Code, so Python extension for VS Code. And I just wanted to show you that if you're looking on GitHub, this is GitHub, the website, not Git, you can see that right here, this repository has 4,500 commits and 22 branches. So if I click on commits, I gotta accept this. Let's see this go through here. Okay, so I'm in commits now, and you can see that this is what I'm talking about. I say branch master, and here you can see all of the commits that have happened, that have been pushed into this branch. So it shows you on what day all of these commits happened, and then you can click on a commit. Let me just click on one here, and let's just have a look at what this is. You can see the things that have changed in all of the different files and what actually happened in this commit. So that's why it's really valuable to have these different branches and to have these commits, because you can look back at the history of anything that's happened in this repository. Now, if you go to branches, you can see that there's a bunch of branches here that people have been working on. And these are branches that are off of the master branch, right? So let me click on my branches, and you can see that I haven't pushed any branches to this repository, but if I go to maybe active branches, let's see how many active branches we have. We have all these branches that are currently active that people are working on. So that is what I mean by branches and commits. And now I want to get us started with our first GitHub repository. So the first thing that we need to do is actually download and install the tool called Git. Now this is going to be the same on Mac and Windows, all of the commands that I show you, but you need to go and download and install Git. I'm going to assume most of you have this, so I won't go through the steps, but I will leave a link in the description that has the link to download and install Git. Once you have that, what we're going to do is we're going to start by making a local repository on our machine and experiment with how all of those things work, and then we'll talk about remote repositories. So let me actually change directories to my desktop, if I could make it there. So I'm on my command line. CD stands for change directory. This is a common tool. You're going to see me use some command line tools here. I'll explain what they do, but these should be the same on Mac and Windows and Linux as well, so don't worry about that. But get into your terminal. So open a terminal, open a command prompt, and then go to your desktop or go to some location where you're okay to make a new folder and type mkdir and the name of your folder, which in this case I'm going to call test_repo. So this is going to be my test repository. This is what I want to just kind of experiment with. So I'm going to make a new folder on my desktop. That's what mkdir stands for, make directory, called test repo. Next, I'm going to cd into my test repo like that. And now what I'm going to do is initialize a new Git repository. So there's many different ways to kind of start up a new Git repository. The most common way if you're working on a brand new project and you're starting it on your local machine is to type git init. So let's say that you're about to start working on something, you haven't worked on it yet, and you're just booting up the repository, it doesn't already exist. What you do is you type git init, and that will make whatever folder you're inside of a GitHub repository. So keep in mind, you can do this anywhere, but as soon as you initialize a folder as a GitHub repository, anything inside of that now is going to be tracked by Git, and what that means is that you can add files, you can use all your Git commands within this folder, but only if you've initialized a Git repository. So here, let me just type git commit, and you'll see that this works, everything's fine, but if I actually cd back, so I cd back to my desktop, and I type the same thing, so let's go git commit, that it says fatal, not a Git repository. So just make sure that you're actually in a Git repository before you start doing all of these Git commands. Okay, so I've made a Git repository, and what I'm going to do now is I'm going to open this up in Sublime Text. So I'm going to go File, Open Folder, test repo is right there, awesome. And now I'm just going to make a new file. So File, New File. Let's just name this readme.md, and let's save that inside of test repo. And let's just make this is a markdown file. Let me just do #hi. So that's just like a header I've just made in a markdown file. Great, so I have that now, and I've made a change to this repository. So let's imagine, I added my code, I'm in the repository, I've made a new change. the first thing I need to do if I want to commit or kind of like store this change, so I want to make that checkpoint, is I need to add all of the files that I want to actually commit. So this is where we talk about something called a staging area. So inside of Git, what we have is a staging area. This is where we're temporarily adding or removing files that we want to be in our next commit. So let's say I added that file, right? And I believe I called that test or something. What I would do if I want to add this to my next commit, I'm not committing yet, but I want to add it in, and this is a temporary area called the staging area, is I type git add and then the name of the file, which in this case is readme.md. So let's do that. We see that nothing goes wrong, everything happens fine. And now if we want to check what we actually just did, we type git status. Now you can see that it says we're on the master branch, which is by default just our core branch. We don't need to make that or anything. It says no commits yet, and it says changes to be committed. It says we made a new file called readme.md. So that is because I added this readme file to the staging area, then I typed git status to look at what was happening in the staging area. Okay, so I had a small error there, but anyways, we now have this file inside of the staging area. So we've added this in, and now what this means is that it is ready to be committed. So I can go ahead and add more files into here in the staging area, and when I'm ready, when I've made the changes that I want, I can go ahead and commit. Now usually you commit once you've made some kind of progress. Once you have something that's kind of working, or maybe you're like in the middle of something and you want to store it at that point, that's when you make a commit. You're not really doing it like every 5-10 minutes. You might do it like every few files you change, or every like, kind of milestone you hit when you're programming, if you want to put it that way. But anyways, once we have that staged, what you can do is type git commit -m, which stands for message, and then inside of quotation marks, you put what's known as the commit message. Now the commit message should be something that's under 50 characters long and accurately describes what you changed in this commit. So in this case, what I did was I added readme.md. That's what I did in this commit. I made a new readme file. So I'm going to type git commit -m added readme.md. Now look what happens. It says master root commit. This is actually the commit ID. It says added readme.md, one file changed, one insertions, and create mode something readme.md. So now we have just committed that file and we've made a change. Now if I actually type git status to look at our staging area, we see on branch master, nothing to commit, working tree is clean. And that is as easy as it is to make a change to a Git repository. You add your files, you make a commit, and there you go. You've now stored that and you've saved that commit. Now, what we can do is look at some other ways to add files and to make commits. So let me go here now, and let's actually make a change to this file. So let me just add another one that says hello. Let me save that file. It's important that I save it. And let's go back here. And now let's type git status. And now when I type git status, we can see changes not staged for commit. So this is telling me what I've made, the changes that I've made that have not yet been staged that I haven't added. And it says, okay, we modified readme.md, and then it says, oh, use git add file to update what will be committed, use git checkout to discard changes in the working directory. So we don't want to do that. What we actually want to do is we want to add this file, we want to stage it, and we want to make another commit. So what I can do is I can type git add in the name of that file, or what I can do is actually type git add period, and what this stands for is add all files. So add everything that I've in the repository, that's what this stands for, just add it to the commit. So when you do dot, that literally means just add everything. So I'm going to do git add dot, that's going to automatically add this file. Now I can type git status and I can see that it says, boom, this is green. We've put this, it's changes ready to be committed. And now we can go ahead and do another commit. So git commit -am, and we'll say, sorry, not am, that's just going to be m, made changes. This is not very descriptive. Usually you want to be more descriptive, but that's okay. We're just going to say made changes. And now, boom, we have our new commit, made changes, one file change, 3 insertions, 1 deletion. Awesome. Next thing I'm going to show you is branches. So let's say that at this point in time, what I want to do is actually want to make a new branch and I want to start working on something and not modifying my master branch. Keep in mind, all of this is happening locally. So I have my master branch of code. we're just going to imagine that this is for one user, just ourselves, because this is a local repository, and I really don't want to mess up the master branch. I don't want to make any changes on there. I want to make them on another branch, and then maybe later on I'll merge that with the master branch. Well, what I can do is make a new branch. So I can say git checkout -b, I believe is actually the command, and then the name of the new branch that I actually want to check out to. So git checkout is how you change between branches. When you do -b, I believe that stands for make a new branch, and now you can put the name of your branch. So what I'm going to do here is just call this branch new. So git checkout -b new. What this did now is to switch to a new branch new. So now what I've done is I've gone from my master branch and I've branched off. So I've copied everything in my master branch onto this branch new, and now any changes I make on my new branch are not going to happen on the master branch. So let's actually split these screens and let's look at this. So let's go here and say new branch inside of readme.md, and let's now on our new branch new make a new commit. So let's say git add dot. Let's add those changes. Let's say git commit -m, and let's make this first commit on new branch. Boom. Let's make that commit, and now let's change back to the master branch and see if the master branch changed. Because remember, I just made these changes on the new branch. So to change branches, what you do is you type git checkout and then the name of the branch. So if I want to go to the master branch, I type master. Since I'm already on the new branch, I can't change to it, right? But let's do this. Git checkout master, and now look at this. Did you see the file? It automatically removed that change because I had made it on the other branch. So now we have two branches, one branch which is ahead of the master branch because it has new changes, and the master branch which has our original changes, right? So let's actually add a new file here. Let's just do this test.py, and let's just say like import pygame or something like that, okay? Now let's make a commit, so let's go git add dot, so let's add all these files. Let's type git status, we have our new file, test.py, and let's do git commit -m added test.py. Boom, inserted that, awesome. Now let's change over to our new branch. So let's say git checkout new. Now I'm on this new branch, and give us a second. You notice that inside of this folder, so let's get rid of that, we have the change that we made previously on that branch, and we don't have the new file that was on the master branch. So let's say that what I actually want to do is I want to update this branch with what's on the master branch. So a change happened on the master branch, which is a new file was created, and I actually want to get that change and bring that to my new branch. How do I actually go ahead and do that? Well, when we're working in this kind of system, what I can do is actually merge the master branch with my branch. So I can actually type git merge and then type master, and what this will do is take all of the changes from the master branch and merge them with my branch. So let's do this. Git merge master, merge made by the recursive strategy, and now look, we're on our new branch here, and we have this test file. We have our readme file that still has this change here, and now we're looking pretty similar to the master branch, except we have this line of code. Now let's change branches again. Let's say git checkout master, and watch, you're going to see that this new branch on line 5 here will disappear. And there you go, it's gone. So we have these two files now, but that line is gone. This is kind of the power of Git, and that is how the two branches work. You check out, make a new one with the -b in the git checkout command, and then you can make commits, you can change, and you can merge these things together. Now that hopefully you have a basic understanding of some Git commands, let's look at setting up a remote repository and get all of this working now in the cloud rather than just on our local machine. So what I'm going to do is go over to GitHub, and I'm going to make a new repository. So you need to make an account and sign in on GitHub. I'm going to assume you guys can figure that out. Now I'm going to go to the plus sign, and I'm going to click new repository. So let's do this, and what I'm trying to set up here is a remote repository, something that other people can look at that's not local on my machine. I'm going to call this one a test repository. I'm going to call this test underscore because test is already taken. I'm going to make this a public repository. I'm not going to give any description, and I'm not going to initialize this with a README file. You can if you want, but for this step, I would recommend you don't, because I'm going to show you how we can link our local repository with this remote repository and push what we currently have up. So let's go ahead and click Create New Repository. Let's give it a chance here. And here it goes. It says quick setup if you've done this kind of thing before. We haven't, so what we're actually going to do is follow the commands that are right here. Essentially, what this is saying is we made a new repository, but we haven't initialized it yet. So we haven't actually set anything up. What we need to do is we need to actually push some changes to this repository first to have it actually be set up remotely. So what it's saying to do here is essentially what we've already done. It says make a new repository on our machine, add a new file, make a commit, and then we need to follow these 2 steps. So what I'm going to do is copy this line of code. You guys are going to need to copy this as well. So git remote add origin, and then this line right here. So make sure you copy this, and at least make sure you have this URL to your remote repository because you're going to need that. So let's go to our command line now. Let's actually put this on the side, and let's type in that line by just right-clicking. So if you copy something and you're in a terminal, you can right-click on your mouse and it should paste it in, and then go ahead and hit enter. What this has just done is added what's known as a remote. Now a remote is essentially a URL to another repository. So what we've done is we've said, hey, I want to add this remote repository as kind of a link, as something that we know of here in our local repository so that we can actually push changes to it and pull changes from it. So that's what we've done when we say git remote add origin. I said I'm adding a new remote that's called origin that has this URL. So now when we use the word origin, we'll be referencing this URL. That's all we're doing. We're literally mapping the word origin to this URL when we type git remote add. You can add as many remotes as you want. Some people will commonly call this also like upstream. So you can have an origin, which is typically your remote repository, because you can work on more than one remote repository. And then maybe like the company's remote repository will be your upstream repository or something like that. Anyways, so we have that. Let me just clear the screen here. And now I'm going to show you how we push changes to this repository. So it shows us here that the command is git push -u origin master. So the first thing I want to do is make sure that I'm on the right branch. So I want to check out. Usually you wouldn't have more branches before you do this, but I want to check out to the master branch. So git checkout master. See, we're already on the master branch, but it's important we're there. And then what we're going to type is git push -u origin master. What this is saying is let's push all of our commits to the origin remote repository, and let's push them to the branch master. So we're picking where and what branch we want to push these to, because we can push to another branch as well, which I'll show you in a second. -u says save these settings. What that means is that next time we do this, all we have to type is git push, and it will automatically remember that it was origin and master that we pushed to. So let's hit enter, and let's see what happens here. Enumerating objects, counting objects, and boom, there we go, branch master set up on track, remote branch master from origin. So now if I go ahead and refresh this here, let's have a look. It says readme.md test.py, and you can see that we look at our readme and we have these changes now on GitHub. So if you had any problems pushing there, I probably know why. I think I probably should have said this at the beginning of the video, but I kind of forgot, so I'm going to bring it in here. What we need to do before we can actually work with a remote repository, and the reason it worked for me is because I've already done this, is set up a username and an email. So don't worry if that push didn't work. Just follow along with what I'm about to show you. This may not work either. This gets a little bit tricky because you do need to authenticate yourself locally on your machine before you can just push and pull from any remote repository, right? So what I'm going to do here is I'm going to start by saying git config -- global user.name, and let me make this full screen actually so you guys can all see it. And what I'm going to do is put in quotation marks the name that I want to be represented by in this remote repository. So on your local repository, it doesn't matter, but on the remote repository, other people will see this potentially, so you want to have some name that identifies you. So I'm going to put Tim as my user.name. So there we go. Now I've set up my global name. So now this is stored on GitHub locally, and anytime I make a change to a remote repository, I push or I pull or whatever, I'm going to be identified by the name Tim. Now the next thing I want to do is use email. So I want to say git config -- global user.email, and in here I'm going to put the email that I use on GitHub. Now this should hopefully authenticate you. It might not. You might have to actually use It might ask you to sign into GitHub. There's a bunch of different things that could happen here. I don't remember how you authenticate locally to be able to push, to be honest. So you might have to look up how to do that. There is something called a personal access token, which you can use as well if you're on Windows at least. But anyways, let's put in our email. So I am just going to put a random email because I'm already authenticated, so this is fine. But I'm going to put tim@gmail.com. Actually, I'm not going to save that because I have another email that I don't want to share with you, but anyways, just put your email and hit enter. And once you've done that, you will have configured your name and your email on Git. So now you can try to push again and see if that works. It may ask you for your password for GitHub. It might ask you to log in. If that doesn't happen, unfortunately, you're probably going to have to go to the internet and figure out how to authenticate. But let's say that now you guys are authenticated and you were able to push to this remote repository. If you were able to do that, what we need to do is move on to the next step, which is understanding how to pull from the remote repository. So I'm in my repository now, I've pushed my changes up, and I'm actually going to make a change on this remote repository. So let's go here, and let me actually go to the edit button, and I'm just going to make a change that's hopefully going to simulate what someone else might change on a remote repository. So let's just move it so that the README only has hello now, and you can see that I can commit my changes right from GitHub. I'll just say updated README, commit changes. All right, so I've committed that now. Let's go back to test, and we see that we've made a change, and that just happened now. Let's go back to our command line, and now let's figure out how we can actually get this change from the remote repository. Well, the way to do that is to use what's known as a pull. So I'm going to say git pull origin master. What I'm stating is what I want to pull, so what I want to do, where I want to pull from, and what branch I want to take. In this case, I want to pull from the origin, which is the remote that we set up, and I want to pull the master branch. So let's go and hit enter, and it says and boom, go ahead, and we have those changes. So that happened, everything worked, and now if I go back to my subline text, you can see that hello is the most recent change because that's what we modified. Now let's do this. Let's make a change here. I'm going to add hi, and I'm going to actually go ahead to this repository here, and I'm going to make a change on here as well. I'm going to put hello, and I'm going to delete, actually, let's see here. I'm going to add hi. I'm going to add hi again on line 4. I'm trying to find a way that I can make this conflict. So let's do this. Okay, so I'm going to commit this change here on this repository. And now what I'm going to do is I'm going to add my change here. So I'm going to say git add because I made a change. I'm going to say git commit -m change. And now what I want to do is I want to pull from this remote repository. Actually, what I want to do is push to this remote repository. So I've made some changes here. I want to push them up to this repository, but notice, and oops, let's go back here, that I made a change to this remote repository that I don't currently have on my local machine. So I changed this just to be high, and I don't have that on this local machine. So watch what happens when I try to push this up to the remote repository. So git push. And you see that it says, failed to push some refs to, and then that origin. Updates were rejected because the remote contains work that you do not have. So what I need to do, and what this is saying to me is, hey, there's changes on the remote repository that you don't have yet. You need to pull those down before I'm going to let you push your changes up. That's what it's saying. So if you get a message like this, what you need to do is just git pull first. So I'm going to say git pull origin master. And now look what it said. It said, okay, boom. We're going to go ahead and we are going to pull all of these changes down. Now look what it says here. Automatic merge failed. Fix conflicts and then commit the result. So what this is telling me is that, hey, we pulled some changes down, but when we pulled those changes, we had a conflict in readme.md. The reason we had a conflict is because we changed 2 of the same lines, and Git doesn't know what to keep. So on this remote repository, I changed the same line that I changed on this repository and this local machine, right? So now if we actually go ahead and look in here, we can see that this is showing me there's a merge conflict. So when you go ahead and you actually do a, you try to pull it down and there's a merge, so it can't automatically there's a conflict, it can't automatically merge the code. What you need to do is manually tell Git what this code should look like. So here, what this is showing you is that, hey, there was a merge, there's merge conflict, you need to fix this. So what you have to do is delete all these arrows, delete all this stuff, and just make this file look how you want it to actually look. So I'm going to change it to look like this. I'm going to save it, and I'm going to resolve this merge conflict. it can't automatically merge it, so I need to manually come in and make the fixes, which I've done. And now what I will do is I will go ahead and I will actually commit this change. So git commit -m change. Okay, so I realized that what I've forgotten to do is just add the new change that I wanted to make. So pretty much what happens is when you have a merge conflict, what you need to do is fix the file, so resolve the conflict. You need to add those changes, and then you need to commit those changes, and then you should be good. So we're going to say git add dot, and we're going to say git commit -m change. Boom, we made the change. That's known as our merge commit. So we committed the merge conflict that we fixed, and now I can go ahead and say git push. So if I do this now, you can see that I'm totally fine to push up to the remote repository because I got the most recent changes, I fixed the merge conflict, and then I pushed back up to the remote repository and I made the change that I wanted to make. That is kind of what happens, and actually happens quite often, is you get a merge conflict, and hopefully you have some kind of software tool. In this case, I have Sublime Text that was able to help me a little bit in fixing that. But all you have to do is go into the file that had the conflict. Sometimes there'll be multiple files. Fix the conflict, add that file back in, commit the change, and then you can push again and pull again, and everything should be working and functioning. Now, the last thing I'll show you is pushing another branch, and then after that, I think we've pretty much covered everything we need to do. So I'm going to say git checkout, and we're going to go to the new branch, and now what I'm going to do is just push this branch up to the remote repository. So I'm literally just going to say git push, and now I'm going to say origin for where I want to push it to, and new. So I need to specify that I want to push this here as the branch new to the new remote repository, so I'm going to go ahead and do that. And now we will push this branch up to the remote repository. So if we come here, you can see that it says, hey, you've pushed a new branch called new, and it says, do you want to compare and make a pull request? Why it's saying this is because it knows that what we commonly use branches for is actually merging them with the master branch once they're ready and once they're good. So let me refresh this here. And notice it says 2 branches. If I click, we can see the new branch updated 17 minutes ago, and let's click on it and go new pull request. Now it says you can't automatically merge because there's conflicting changes. But let me go here and make this a draft pull request. So I'm just going to submit it here, just do this just to show you something. And I'm going to go to files change, and you can see what it's showing me here. This is what I added, and this is what I removed from the previous file. So that is how this works. And this is kind of the basis of merging things into master, is you make what's known as a pull request by having a new branch, and then you compare that to the master branch and you merge them, kind of squash them together. So with that, I think I've covered pretty much everything I can for GitHub fundamentals. I do apologize if this video is slightly confusing. I'm trying my best here to explain everything. Sometimes it's hard to think back to the point where I've never used GitHub before because I've been using it for a very long time. But hopefully that at least gave you a good enough introduction that you kind of understand what's happening in GitHub now. Maybe some of the commands you need to go look up again, but now you have like a good foundation. You kind of understand what a commit is, what pushing is, what pulling is, what a merge conflict is, how to make new branches, all of the stuff that I covered. So anyways, if you guys enjoyed this video, please do leave a like, subscribe to the channel, and of course, I will see you in another YouTube video.